Okie doker, let's get it. I had some shit to do. I was gonna start earlier, but now we start. I had to fucking replace the battery on my laptop and get the mail and some other shit, and then cook and then whatever. So, alright, so last time we learned a bit about templates, so we can do template and then angled brackets type name something. We can specify a bunch of type names. And it's called, what is it called? Not a declaration. There's a word for what the template is before a function. I think you have to make a like a template thing. A template. I'm just gonna say a template definition. You have to define a template right before a function, and that template applies to the function immediately after it. I think. But right now I'm gonna try and see what happens when I put a template. I define a template, and then we put a fucking function after another function. Bro, what is my hair up to? We good? Alright, we're good. What? Just feels weird. Alright, let's get it. So, I was looking at OpenGL for a second too, but I think I want to do graphic stuff later. From scratch if possible, just to see like what I actually have to do to make this shit. So later on I can just make shit, you know? Alright, so let's do what is it? Template? Like that? And then we can do void, what? Aren't you happy? No, it's just that. I don't think I have to do that. Yeah, see, it doesn't want this. It's probably gonna say invalid after. A what? Declarator? Oh, declaration. It's not an R. Just look. Void, do thing, and it takes a T, X. X. Cool. Okay, it's good. But what now if we say void, do something else? Uh-oh. What is T? Okay. So what if we do that? What was the issue here? There's a baby. Does the mic pick it up? No. Oh yeah, it was, I think it's only one or something. Why? Here comes. Clause. What is it called? A template clause? Yes, a template clause. And what it's called a template clause. Noted. Okie doke. Okay. Alright. So yesterday, what would be a good case for using a template? So I want to generate overloads based on what function calls I'm doing. Oh my, why? Oh my god. Oh, that was to start program. What am I doing? Setting it for an hour and a half later. Bop. 9:30. Okay, let's go. Oof. Wasn't ready for the jump scare. What the fuck? Okay. So, what's a good case? Oh, and I played Death Stranding yesterday, not realizing that, hey, when you're getting near the end of the game, you have to play for like 4 hours straight because it's all just cutscenes. So I didn't do my self-test, but I'll do it today. Oh, fan. I need the fan. Alright, what are we doing? An example case for templates. Could I have a type name T and extract something to it and return it? Yeah, couldn't I do that? Could I get anything? No, but that's, well, it doesn't have to be in the declaration or in the signature. The type name could be anywhere, right? So couldn't I do, I mean, I wouldn't want this. I wouldn't want to actually have a function that I use to get anything like I do get fucking breathing, bro. I wouldn't want to do get or yeah, because I have to. The whole point here is it does have to be in the fucking declaration for a template because the template's behavior is determined. The overloads that it generates are determined by what I put into the argument. So what would happen if I put in? Oh, I think I was thinking about this last night, like right before bed or something. I could pass any number. Then it doesn't use it like. So, but then I have to explicitly say. I have to explicitly say it in code because at compile time the templates are. The template is used to generate overloads. So, but I could do a function that returns a something. I fucking ate spinach, dude. I ate spinach and now my throat is all coated in that shit after you cook it. Oxalates, man. Type name T, sure. We'll just stick with that. And then we'll do a T returning get thing. And it takes a type name T. Well, so it returns the type that you pass into it. And value type, we'll just say. Or a data type? I mean, data type example? I don't know what we'd want to call that. It's something that you pass in. Like, I want to get an int, I pass in 5. I want to get a string, I passed in a fucking string. I want to get a character, I pass in a character. And then, the hard thing though is we'd have to use the same shit for each. So I can't do standard character input for an integer if we pass an integer, but then do standard get line. Because I can't, there's no condition for if t is an int, if t is this, if t is that. But we could at least get input and output. Bro, hello? Okay. And we could have a t user value, and then just value initialize it. And then standard character input user value. Is it cool with this? Return user value. We could just say enter a value like yo. Hide! Get the oh, okay, it's not. I thought it was obscuring this. I couldn't see it. It was gray. Like data type example. Or we'll just say okay. And so this would be a way of, like, I could get a character. I could get an integer. And so this would be int get thing. This would be, oh, hi. What happens if we do that? Oh, it's a const character pointer because that's what a C-style string is, seems like. And then we could do a character. And it generates the proper overload. So we just pass in C. And we don't do anything with C. We just, well, we use it as a reference. Okay, what if, oh shit, what if I did AS? Oh, because it's just going to do that and then leave the rest and then it's cool. Okay. Oh, but you'd still have to handle invalid input. But we could still check for that too. It's like, what if I did, well, 3 is obviously still character. All these are still characters. What would be a case? We could do like an integer. Oh, and that gets 0, huh? Or what if we did A5? Interesting. Wasn't that how that worked before though? like when there was no template here, and this was just an integer. And then this was just get thing. Go. Oops. Doesn't need that. How was it again? There was a way that we could put an input and it would fail the buffer. In this case, it's an integer. And if we put in a character, it just overflows. Yeah, I'm not sure how I get it to fail. Oh, duh. The point, it's because that's when we have like a do while loop. So it's and it's when extraction fails. So what if we said oh, I think we just do true, right? And then we just return the user value if it's good. So we prompt the user, get the input. What happens if we do this? Or what if it was what? Yeah, honestly, I don't remember. I don't remember how it was overflowing before. Just before it would fail, and then yeah, I don't know. I don't remember. Whatever. Okay, so yeah, the general idea of what a template is. So we create a function template, and then anything we pass into it, like putting in a piece of paper underneath some sort of stencil, some sort of template IRL, well, the template would do its thing depending on what it's passed. So if we pass it an int, then it does something for an int. And specifically what it does is it actually makes a function that can then be called. So it's like a generator for function, or a compile time generator for function overloads. And a new one is generated for each set of parameters input or that it's called with. Okay. Yeah, type template parameters, that's what those guys are instead of template types. That doesn't make any sense. Oh, why do I feel weird inside? Guess it's the feeling of leaving work unfinished at work or something. Or maybe that I'm flying out. I don't know. So weird. Like I wanna, I don't know. I'm working on some VBA code stuff at work for Microsoft Word so that I can automate something. And it was fucked up still. Guess I'm wanting to wrap it up soon. Maybe that's what it is. Alright. Dude, and the fucking breathing is so annoying, dude. Is I could make a template for somebody and then you just call that function or call that call that function call the function that uses that template clause and it will generate the actual the instances of that function. So our type template parameters. So different types of template parameters, okay? They're types, non-types, templates. So type, I could see it's generating the functions of different type taking instances, depending on the calls. The parameter references a cost expression value. Why would you want that? Is the point that you wouldn't just do that? You would also have the type template parameter just like normal, but then you might have. What is the purpose of having it be a const expression value? I mean, that const expression value is somewhere. Well, I guess it doesn't have to be somewhere in memory. It could just be a literal that the compiler is using, and it's in the code. Doesn't that mean it's in the memory somewhere? Like a C style string, literal, is created at on program start and lasts forever. Or at least that it lasts. It might not be that it. I think so, though. I think it has static duration. Const expression value? And then template type parameters. Okay. A max function. So instead of saying int max whatever, just do the type. Okay. Only thing is we have some comparisons going on here. Well, the comparison is fine. It's just that it's not equivalency. So as long as we're not doing that, we should be okay for floating point values. Okay. So we'll say template type name t. We want them to be both the same type, and we'll say t returning max. Excuse me, and it takes a t value 1 and a t value 2. And it returns value 1 is greater than value 2 if it is, then it returns value 1. Otherwise, it returns value 2. I wish it would bring the fucking cursor back to where it was after compiling. And then we just... Okay, and this is at compile time, so I have to pass the value to it at compile time. So we'll just say output max 3 and 2. Output's 3, or we could say and I could void print max, or I could just do this. And we could say, and in this case, it's doing, oh, the point is that these two types are different. So it's not going to just implicitly convert, it's actually going to flag and say, hey, you only have a template, buddy. Or rather, it's going to say that, hey, your template says that these two values must be the same type. I'm not going to just convert it to that. So if you have a template, implicit conversions, it looks like they're not being done for it. Yeah, it makes sense. What if we say 2 point, which goes to 2.0, it's a double. Cool. Okay, bro, there's no fucking template here. What? Dude. How do I turn this off? Ay, ay, ay. What do I just add something? Yeah, fuck it, I can just do that. I bet you I can just compile. Okay, and then sometimes it's just gone. I don't know. Okay. Note that we can use, or yeah, we've used int 3 times here for each parameter and the return type. Yep, so it could be the same for each. Okay. Dude, I'm so phlegmy after the spinach or something. And I'm mouth breathing because the breath is terrible. Breathing. Well, yeah, T isn't a thing. Yeah, it doesn't know it. It doesn't know that it's a data type. So you need a type name. Yeah. Both of these are done using a template parameter declaration. Okay. Strictly limited to the function template or class template that follows. Meaning that this is a function template. Interesting. So this is the declaration of the template parameters for this template. And so we're actually calling a template. And then the compiler is generating the relevant function. Assuming the template definition and our argument call match. Gotcha. So that's what we call it. We call it max T. Mm. Okay. Fan is off. Okay. Yep. Multiple template types in 11.8. Bro, two more later? Two later? We already did this shit earlier. Hello? I passed it one thing, and then it does another thing. Ooh, could I print T? I I don't think I can. It's probably going to complain that we're not using the, No, it's not? Interesting. What if we say... Oh? Oh, shit, we can! Oh, wait, hold on. What does that mean? Type name T? What does that mean? T is a type, but it's not known. So later, T becomes that type. So if we... What happens? Right? Yeah. Makes sense that nothing's matching. We need a fucking T in here, yo. So we'll say T number. Okay? And we'll say 5. Oh, wait. Well, we're not using it. Hold on. Go. Oh, wait. T. Sure. Oh, well. We're just gonna do... thing. Type int expected. You motherfucker. What do you want? What if I just printed int? Fuck. I can't just print it. Damn it. I have to type something else to do. Oh, it's so annoying. Okay. Man, I was hoping I could print the type of something. I think you have to include type or fucking, what is it? Type info or something like that. Yep. No difference between the type name and class keywords. Yeah, instead of, oh yeah, because class. I'm not sure how data types and, well, it seems like classes are for objects specifically. And sure, data types are too. They are also for objects because variables are objects. But those data types are already predetermined. Maybe, at least some of them are. So it seems like there's, I guess a data type is a type of class. This is just a class of an object. It's a type of an object. And in this case, it's by default described by a type name or a data type. But we could create, if we create other objects, we need to call them by class, I guess. I don't know how this this backslider thing keeps sliding not how I need it. It'll be like way up on my back or way low and I just won't notice. Any type, meaning including a class type, seems like, huh? So we could do type name T, and then I could pass it a fucking class, and then it would deal with the class. And if I have two classes that are somehow comparable, then I could pass it two classes and have two type names for those two classes we pass it. Am I on 240 hertz or what? Feels like I'm not. I guess so. It doesn't say what I'm on, really? Whoa, bro, hell no. It almost feels like I'm not actually on 240. Oh, okay, that is what I was on. Why was it doing shit a second ago? That was weird. Okay. Just wanted to make sure. Mm. Meaning to generate and actually call it? Don't you simply call it with the types in the argument with types of arguments and then that function that you need is already is created? Single capital letter when it's trivial or obvious. Okay. That can be compared. Interesting. I guess no pointer is different from some other types of pointers and they can't be compared for some reason. Or maybe it's just that you can't pass it a variable of type no pointer. Okay. It's non-obvious. Capital letter. Prefix with a T. Two common conventions. Just capital or T capital. Yeah, instead of saying allocator X, bro, just say T allocator X. Seems like that makes more sense. It makes more sense. Yeah, I agree. Template class T. Class compare. Two different ones. And we're saying a constant T, and it's a reference, I guess, a reference to the T. So it's some sort of value that's passed back, and it matches the types of the two parameters in the beginning. And then there's compare, which is another type for some reason. We don't care what A and B are, they can be any type and they match. It has another type, okay. Places the template parameters with the arguments. Compiles the function depending on what those data types actually need to be. So like how they're being used. Yeah, so if we have a template and we're anticipating passing integers to it, but inside it updates an unsigned int to get the value from the integer, well, it's probably unlikely that it's going to work because we're probably going to get at least a signed unsigned narrowing conversion warning, if not error. Oh, meaning because if we're using this and it's already existing, it's just like me reading someone else's fucking code, and I see these classes, and I don't see the implementation. Bro, I don't know what the fuck compare needs to be. I have no idea. And so it's max, and then what are we comparing it to? I really don't know. And so I gotta say, yo, Jim, What the fuck? What are you talking about here? Let me see your definition. Let me see the documentation. A single capital letter to name the template parameters that are trivial. If it's non-obvious, make it T something with a capital T, and then capital something else. Describe why construction blueprint. So this is just a life question. Construction blueprints are a type of template. So if I have a construction blueprint and it says, hey, you're making a house that looks like this, and it has a door, and it has a this, and it has a this. The specifics of what we're doing, I mean, we know the process of what we're going to do, but exactly what we're going to do, the actual implemented version, will depend on the materials that we get. Specifically, like, oh, you want granite countertops? Sure. My template, my blueprint, my construction blueprint was ready if it was wood countertop or if it was freaking glass countertop. And yeah, even if it was a granite countertop, we're good to go. The template is ready for whatever you put at it. Maybe, however, you fill my template with information that doesn't work. If you don't give me enough shit, well, or you do something wrong, like I don't know, my template says that the door will open up like this no matter what the fucking door is made out of. It could be made out of damn obsidian. Nobody cares. But if you're passing me a freaking door that's shaped wrong, well, it can't be used properly in any function, so we're screwed. Yeah. Well, yeah, we know that the whole process is the same. It just depends. The specific implementation depends on the specific shit we've got. Exactly. The material types. Yep. Yes. Exactly. And we can't determine it until it's then. That's it. So if we say, hey, I'm gonna build a house for you people, somebody here. One day when someone actually contracts me, well, I already have the template built. I know what the house is going to look like. We've already designed that. I said this is kind of the kind of house I'm going to build. But the person who's moving into the house has the ability to determine what the shit is made out of. Okay. I'll pause here for a sec.